Okay. Hi, my name is Deepak Kohli. I'm part of the IMS product management team at the IMS lab at IBM. And today I'll be talking about implementing the IMS catalog. This is a very direct presentation where we'll just lead you through the step by step of what needs to be done to implement the IMS catalog. The next page is just a disclaimer page, so that's there because legal wants it, and I'll just skip over that. Here's the agenda. I'll give you a brief introduction to, or a brief overview of what the IMS catalog is. By brief, I mean about 10 slides or so. And then I'll talk about the IMS catalog implementations. We'll give you a high-level overview, and then we'll go through each step one by one so that you can easily implement the IMS catalog at your site. On to the next page. This is a title page, Brief IMS Catalog Overview. There it is. And I'm now moving on. So what is the IMS catalog? This was an optional system database introduced in IMS version 12, and it stores IMS application and database metadata. You know, just like DB2 has a catalog, IMS now has a catalog starting with IMS version 12. It's optional. You don't have to implement it, but it has become a strategic direction for the IMS lab. So as more and more features are added, they will take advantage of the catalog. So at some point, you will be implementing the IMS catalog. The IMS catalog is what we call a HAL-DB database, high availability large database. It's a trusted online source of IMS database and application metadata, fully managed by IMS. You can access the catalog using JDBC calls or using SQL calls from your COBOL programs. This is a feature became available in IMS version 13, known as native SQL support, or you can issue DLI calls to access the catalog because the catalog is an IMS database. The universal JDBC drivers that are used to write Java programs that issue JDBC calls to IMS database can also leverage the IMS catalog for metadata information. The catalog is part of our IMS simplification and integration strategy, and this is the foundation for newer features that we are now making available. So in version 13, for example, we've got something called database versioning. You can't use it if you don't implement the catalog. So with that said, on to the next page. Here are the products that can use the catalog, the IMS Explorer for development, Cognos 10.2, Infosphere Data Architect and DataStage, Data Studio. So all of these products that are out there that sort of can consume metadata information is now available in the IMS catalog. I mentioned this on the previous page. I'll say it again. Any Java programs that use the universal JDBC drivers to access IMS databases need metadata information. Prior to the catalog, you had to generate those metadata class files. Now you don't have to do that because universal JDBC drivers can take advantage of that information that's in the IMS catalog. And of course, information in the IMS catalog is useful for metadata discovery. So things like which PSBs have PCBs with labels, which databases have exits, which PSBs access which databases. Those kinds of searches you can now do against the IMS catalog. And I mentioned this before. Here it is again, the new features in IMS version 13, things like database versioning, native SQL support for COBOL programs, .NET access to IMS data, all require the IMS catalog. On to the next page. The title is Before the IMS Catalog. Before the IMS catalog, metadata for IMS databases and applications was spread out. You had some information in the DVD lib, you had some information in the PSB lib, and then that information was sort of put together in the ACB lib, and then the database segments and fields and what the data types were, that was stored in what's known as COBOL copybooks or PL1 declares. If you were writing Java programs, it was in Java classes. So it was all sort of spread out. There wasn't one central place where all this information was. On to the next page. The title is With the IMS Catalog. So with the IMS Catalog now, we've taken all this information, you know, the database, the structure, the fields, the segments, the data type, all of that stuff now resides in one central location, and it can be consumed by various tools, as I mentioned before. Updates to the IMS catalog are done only via an integrated IMS process. There's a catalog populate utility that I'll talk about later on and show you how you can use that to populate the information into the IMS catalog. And I think I mentioned this already. The catalog is a key component of the IMS simplification and integration process. Come on over to the next page. The IMS Catalog Database, a little bit, some more details on it. It contains DBD and PSB and application information. It's actually a HAL-DB database, and there are different types of HAL-DB databases. This one is a P-HIDAM OSAM database. So it's a partitioned HIDAM with OSAM as the underlying access method. We've got 4 dataset groups defined for performance reasons. And it has one secondary index which can be used to cross-reference DBDs and PSBs. Now, if you're an IMS customer and you used HAL-DBs, you know that HAL-DBs have to be defined to DBRC. But for the catalog, DBRC usage is optional, right? This is the only HAL-DB in IMS that does not require DBRC. So, for test environments, for example, lots of customers in a test environment don't use DBRC. For those customers, you don't have to define the catalog in the DBRC. IMS can manage allocation and creation of the catalog database datasets. There are parameters in the IMS Worklight member DFS-DF. There's a catalog section in this Worklight member where you can define the parameters that can be used by IMS to allocate and create the catalog database datasets. On to the next page. The heading says IMS Catalog Database. IMS provides the source code for the catalog database. IMS also provides the object code for the catalog DBDs and PSBs. The P-HIDAM DBD is called DFS CD000. The secondary index DBD is called DFS CX000. These are all reserved names, by the way. PSBs that have been created to reference the catalog. Here they are. DFS CPL00 is used for the initial load of the catalog, and that's used by the catalog populate utility. The PSB DFS CP000 is used to access the catalog by COBOL or high-level assembler programs. DFS CP002 is used by PL1 programs. DFS CP003 is used by Pascal, and all of these PSBs provide read access. DFS CP001 is a PSB that's used for update access, and that's used by the ACB Gen and the Catalog Populate utility, which is a brand new utility, and I'll talk about that. And there's a purge utility that can be used to remove entries in the catalog, and I'll talk about that, but this PSB is used by the purge utility also. IMS automatically adds its PSBs for the IMS catalog to any user PSB at runtime. This way, if programs need to access the catalog, they can. ACB Gen is required for all catalog PSBs before enabling and populating and using the catalog. And I'm going to talk about that in more detail when we get into the steps of implementing the catalog. The root segment of the catalog database is a generic resource header. It indicates whether what lies underneath it is a DBD or a PSB. And a dependent of the root and its children are simply a complete DBD or a PSB. And each segment corresponds to the macro that you code in the DBD or the PSB. There is a place in the catalog where vendors or customers can store information. There's a segment called DBD Vend for vendors or customers to store information for DBDs, and PSB Vend for customers or vendors to store information in the PSB. Every time you do an ACB Gen, an instance of that is created in the catalog. So you'll hear this term more and more. An instance of the IMS catalog metadata is generated each time you do an ACB Gen. In the DFS-DF Worklight member, you can configure how many of these instances are stored in the catalog. And then we came up with this instance concept because, with ACB lives, you've got two ACB lives. You've got an active and an inactive. And whenever you change an ACB live, you do it in the inactive, and then you do a switch. And so people might have this conception that, oh my God, are there multiple catalogs? And the answer is no, there's one catalog, but within the catalog, we can create multiple instances of the ACB members. And we attach timestamps as to when the ACB gen was done to separate those instances. On to the next page. The heading says Physical Catalog Structure. So this particular page here gives you the physical hierarchy of the IMS catalog. And as you can see, basically we've got DVD information and PSB information, and all the segments here correspond to the various macros that you code in the DVDs and the PSBs. There is one secondary index. There it is, DFS CX000, and that's used to correlate DVDs and PSBs. So that's my brief introduction to the IMS catalog. And now let's talk about implementing the IMS catalog. So this is a title slide, implementing the IMS catalog. There you see it, and now I'll move on. So here it is, the top 9, if you will, the 9 steps to implementing the IMS catalog. So let me sort of go through this with you, and then we'll take each step and go into a little bit more detail, and then you'll have at your disposal a way to easily implement the IMS catalog. So the first step is, IBM and IMS provides the DVDs and PSBs for the catalog, and they are in the SDFS ResLive dataset. So you want to copy the DVDs and PSBs from the SDFS ResLive dataset to your DVD Live and the PSB Live. And I mentioned some of the names of these DVDs and PSBs previously, but I'll mention them when we go into detail on the next slide. Once you've copied those object DVDs and PSBs into DVD Live and PSB Live, then you run the ACB gen. You run the ACB gen for those DVDs and PSBs, and that's step number 2. Step number 3, now you activate the ACB library that contains the IMS Catalog ACB library. Just basically you're doing an online change. That's what it is. The next step is to define the HAL-DB master and the partitions of the IMS catalog. And here again, you've got 2 choices. You can define it to DBRC, which is sort of what's recommended, but typically in a test environment and in development environment, most customers have DBRC turned off. And so if you don't define it to DBRC, especially for a test environment, you may not want to do that, then we have another option, and that's called the Catalog Partition Definition Dataset Utility. So that we actually provide a utility, a separate utility, to define the HAL-DB master and partitions in a separate dataset called the Catalog Partition Definition Dataset. And we'll get into that in more detail. Step number 5 is you go into IMS ProcLib, and in the member called DFSDF, there's a catalog section in that member, and there you define catalog-related parameters. And many of these parameters have to do with whether or not you're enabling the catalog, allocation-related parameters, and so on. And we'll look at some of those parameters when we go into Step 5 in more detail. And then IMS will automatically allocate the catalog database datasets for you, but if you'd like control, and some people do, then in Step 6, you want to manually allocate the database datasets for the IMS catalog. And then Step 7, once you've got the database datasets allocated for the catalog, now you've got to load the information in there, right? So you load the IMS catalog by running the Catalog Populate utility. And here it is. There's that name, DFS3PU00. So I'll talk about the Catalog Populate utility in more detail when we get to Step 7. Once you've got the information in the IMS catalog, it's populated, now you're ready to use it. But before you do that, Step 8 says it's a good idea to take an image copy of the catalog because it's a database dataset. What happens if it crashes? How do you recover it? So you want to start off by taking an image copy of the catalog. And then you simply restart IMS, and IMS will start using the information from the catalog. So that's a high-level look at the steps, the 9 simple steps that are required to implement the catalog. So now I'll go through each one of these steps in a little more detail. So let's do that. On to the next page. Step 1 says IMS supplies the DVDs and PSBs. Copy them from SDFS ResLib into your DVD Lib and PSB Lib. So here you'll see we've got an IAB copy JCL all set up for you. You can use this JCL, and you'll see that the DVD names are called DFS CD00. That's the IMS Catalog Database, and DFS CX00. That's the secondary index database. And then you've got the PSBs, DFS CPL00, DFS CP000, DFS CP001, CP002, and CP003. So you want to copy these DVDs and PSBs from DFS ResLib into DVD Lib and PSB Lib. So that's step 1. It's coming over to step 2. Now the next thing you want to do is do an ACB gen for those PSBs. Once you've done an ACB gen, then you want to take that ACB library and make it active. So you basically issue an online change command. So you run the online change copy utility to back up your active ACB library, initiate the online change commands, and that'll copy the information, and now you've got the active ACB lib all ready to go. So that's step 3. Coming on to the next page, page 17, this is step number 4, defining the HAL-DB structure. So you want to define the HAL-DB structure to IMS. Partitioning of the catalog is the user's responsibility. So, every client, every customer out there is going to have a different size catalog. Somebody may have a huge catalog, somebody may have a medium-sized catalog. The number of partitions is going to vary from one customer to another. So you need to decide how many partitions you're going to have for your catalog. Of course, minimum of 1 partition is required. The last partition must be able to contain the highest key PSB record. The catalog HAL-DB, as you can sense already, uses a high key selection method, right? That's how we do the partitions, is based on keys. There is no partition selection exit that you can use for the catalog. The catalog database definition for systems that use DBRC or for environments where you use DBRC, the catalog database can be defined to the recons using the DBRC utility and commands. For systems that do not use DBRC, then you can use the catalog partition definition utility, which is DFS 3UCD0, and that utility will then define that same information that typically you would put in the recons. That same information would be stored in the catalog partition definition dataset. If an alias is used in the catalog section of the DFS-DF member, then each alias catalog database must be defined. And I'll talk about why you might need an alias a little further down the road. So here on the next page, this is page 18, we are showing you how to define your catalog database and partitions to DBRC using the DBRC utility. And here are the commands. The init.db command is used to define the DFS CD000, and then the partitions are defined using the init.part command. And then similarly for the secondary index, there's an init.db command to define the DFS CX000 database, and then the partitions are defined using the init.part command. So this is how you would define the catalog and its partitions to DBRC in the recons. If you are using catalog alias prefix, then in this example you want to replace the DFSC in the database and partition names with the 4-character alias name that you specified in the proclib member in DFS DF proclib member. And again, I will get to why you might want to define alias names later on. On this next page, page 19, the heading says IVP support of the catalog. There are jobs and tasks that have been added to IVP in support of the IMS catalog, and here we've just listed the various jobs and the tasks that are available to you. IVP, by the way, is what we call installation verification support. So when you're installing IMS, there are certain jobs and tasks that you can run to verify that the installation went well. All right. So come on over to the next page, page 20. So here now we're talking about, this is that case where, well, what if I don't have DBRC turned on? How do I define my catalog database and partition information? Well, then in that particular case, you would use the catalog partition definition dataset utility, DFS3UCD0. That's the name of this utility, to define the catalog database information. And this, you'll see here that the DD name, DFS HDBSC, is the DD name for the catalog partition definition dataset. That's where all that information that typically goes in the recon will now go into this dataset. And you'll see what we're using in the sys and DD cards here is we're using HAL-DB equals part equals. It's the same sort of information that you typically specify in the recons for DBRC. But here, we're specifying the HAL-DB, the part information, the DSN prefix, and the key information. That's all going into this catalog partition definition dataset, the one with this DD name DFS HDBSC. All right. So this is when you're defining your catalog this way, where you're not defining it to the recons, we call this an unregistered catalog database, right? And by the way, when you do this, of course, when you define something to DBRC, DBRC will keep track of all the recovery-related information. Well, here, if you're doing this, well, you can't rely on DBRC to provide that recovery-related information for you. Okay? On to the next page. So when you are using when you're not defining the catalog to DBRC, in the DFS-DF Worklight member, you also need to specify that this catalog is unregistered. So in the database section, there's a keyword called unregistered catalog equals, and this is where you would specify the catalog database name and the secondary index database name. And I think I already mentioned this at the bottom of the page. Limitations of using an unregistered catalog database: no IMS data sharing support is provided because no DBRC is involved. No online reorg support is provided. No partition definition change support is provided. The user has to rebuild the catalog partitions. And manual recovery is required for unregistered catalog databases, which is sort of, understood. And again, this is really designed, I can't imagine in production anybody doesn't have DBRC turned on. I think everybody now has DBRC turned on. But in test environment, you might want to make it unregistered because you don't have DBRC turned on. Okay? On the next page, page 22, what you also want to do is you want to create a dynamic allocation member for this catalog partition definition dataset. And so here we're just showing you JCL on how to create a catalog, how to create a DFS-MDA dynamic allocation member for that catalog partition definition dataset. Right? On to the next page. Okay, so we've defined the catalog to either DBRC or not to DBRC. Now there are parameters that we need to code in the DFS-DF Worklight member. There's a catalog section in DFS-DF Worklight member. You can have a single catalog section. You can say section equals catalog and list all the parameters. Or you can have what's known as a multi-section format. And for a multi-section format, you say section equals catalog followed by the IMS ID. And the reason you might want to have a multi-section format is when you've got multiple IMS systems sharing one DFS-DF Worklight member. So if you've got multiple IMS systems sharing one DFS-DF Worklight member, so within it you can separate the catalog sections by coding catalog followed by the IMS ID. Right? The catalog definition user exit, DFS3DX0, is also provided as an alternative for batch processing environments, this is DLite batch we're talking, that do not use the DFS-DF member of the Worklight dataset. So let's go through some of these parameters. Catalog equals yes or no. Do you want to enable the catalog for your IMS system? Yes or no. The default, of course, is no. If enabled, if you say catalog equals yes, IMS automatically creates the catalog DDIRs and PDIRs at IMS startup time. Typically, IMS gets that information from the ACB lib. But if you say catalog equals yes, it'll go to the catalog and grab that from the catalog. You can also specify an alias. And remember, earlier I kept talking about alias, and I said I'll get to it. Well, here it is. Right? You can also you'll notice that all of the catalog database names and the PSB names begin with DFSC. Well, you may want to create an alias, a 4-character alias. And you can do that here. You can say alias equals and specify a 4-character alias. Why would you want to do that? Well, it enables use of non-shared alias catalog databases within an IMS Plex. You would want to use this in a data sharing environment where each IMS has its own catalog database and all are registered in a single set of recons. At runtime, of course, the alias catalog database names are dynamically replaced by IMS internally by DFSC. So that may not be clear right now, right? So let me show you a picture. Picture always helps. So coming on to the next page. So here it is. Take a look at this. I've got 4 IMS systems, right? IMS 1, IMS 2, IMS 3, IMS 4, and they're all involved in data sharing, so they're all using one set of recons. But they're all having their own separate catalog, right? So how do you define them to the recon? Well, you can't, because they've got, you're using the same recon. It would be very difficult if they all had if the catalogs had the same name. So this is an instance where, because you're doing data sharing, you've got one set of recons, you want the catalogs to have different names, so you can specify aliases. So for IMS 1, my catalog has an alias called CAT1. That's the first 4 characters, CAT1. IMS 2, the catalog has an alias called CAT2, and so on. So this is an example of why you would have to have an alias in this particular instance. Okay? On to the next page. We're still looking at the Worklight member DFS-DF. Here are some of the other parameters. If your catalog is SMS managed, then you might want to specify data class, management class, and storage class. This is for SMS managed datasets. You might want, there's an IX Valsier parameter. This is where you specify the Valsier number for your primary and secondary catalog indexes. This would be if it's not SMS managed. Space allocation. Here you can specify the percentage of free space added to the catalog to the IMS computed size for the primary and secondary dataset allocations. So whatever IMS, we talked about earlier that IMS can allocate the catalog datasets, right? So it comes up with a size. It looks at the ACB lib and it comes up with a size and it allocates the database datasets. Well, you might want to say, you know what, add another 50% to it, or add another 37% to it. So you can do that with the space allocation parameter. And then SMS volume count is the number of volumes created by the catalog populated utility for SMS managed datasets. A couple of other parameters on the next page. The retention equals. As I mentioned earlier, whenever you do an ACB gen, we will create instances of those in the IMS catalog. And so the question is, how many instances does the catalog hold? So you can specify that via the retention parameter. So you can say retention equals, and you can say instances equal, and it'll keep up to, say you say instances equal 5, it'll keep up to 5 instances. Or you can specify days equal, and it'll keep instances up to a certain number of days. The default value of 0 disables this feature. And you can specify instances parameter, days parameter, or you can specify both. There's another parameter called GUR cache equals, and this specifies the amount of storage in gigabytes to allocate in 64-bit memory the cache XML documents that are generated by the getUniqueRecord call. There was a brand new, when we introduced the catalog, we introduced a brand new call called getUniqueRecord, where it gets the entire record in the catalog, not just a segment, but the entire record. And it gets that information, puts it into an XML document, and so how much space you want to allocate for those XML documents, you can specify that with the GUR cache parameter. Okay? On to the next page. So now you've specified the parameters in DFS, DF Worklight member. Now, if you want to, you can manually allocate the database data sets of the IMS catalog, or IMS will create those for you. Okay? Come on over to the next page. Now we're talking about populating the IMS catalog. There's a catalog populate utility that's become available. It's called DFS 3PU00, and it loads the IMS catalog with information from the ACB lib. It reads each ACB member, decodes it, converts it to a catalog format, and loads that information into the catalog. The input to the catalog populate utility is the ACB lib, the DBD lib, and the PSB lib datasets. The datasets can be concatenated, but only the first occurrence of the ACB member is used. The reason we need the DBD libs and the PSB lib, well, the DBD is needed for logical databases and GSAM databases, and the PSB lib is needed to determine which GSAM databases go into the catalog. And I think I mentioned this already before. Here it is again. The catalog, database, DVD, and PSB segments will have a timestamp that matches the ACB member timestamp, and this is used to keep the ACB lib and the catalog library in sync. The only exceptions to the timestamp are the DVD gen timestamp is used for logical and GSAM DVDs, and the PSB gen timestamp is used for GSAM-only PSBs. Come on over to the next page. Again, we're still talking about populating the IMS catalog. If any of the database datasets do not exist, we're talking about the catalog database datasets here now. The catalog populate utility will automatically create them for you. For example, DFS CD000 is our HAL-DB database for the catalog. So it'll create the primary index dataset, it'll create the ILDS dataset, and of course 4 dataset group datasets for the segments of the IMS catalog. And it'll create the secondary index dataset, the DFS CX000. The catalog populate utility calculates the size of the database datasets based on both the size of the ACB library and the expansion parameter that we coded in DFS DF Worklight member. All right. On to the next page. The catalog populate utility can be run as a BMP job or as a DLI batch job. It requires IMS logs for backout and recovery. It requires IRLM if the catalog is shared and the catalog is active in an IMS subsystem. This is what we do in a data sharing environment, so this is nothing new. The catalog populate utility requires DBRC if the catalog is defined in the recon. Otherwise, if using the catalog partition definition dataset, then it's your responsibility to ensure that the catalog access has ceased. I think on the next page, we've got a picture of the catalog populate utility. Here it is. This is the picture of the catalog populate utility. The inputs are the ACB libs, the DVD libs, the PSB libs. It also reads the DFS DF Worklight member, so it knows values of things like the expansion parameter that you specified. And the output of the catalog populate utility, the sysprint you see here, includes a report that contains statistics about the record segments that are loaded into the IMS catalog. The report includes information about the number and types of segments, as well as an estimate of the amount of DASD storage each dataset group of the IMS catalog will require. Now, by the way, this is important stuff. If you need to know how much DASD storage the IMS catalog database datasets will need, you can run the catalog populate utility in analysis mode. And then it'll tell you, it'll give you the sysprint, and it'll tell you how much information you would need, how much storage you'd need for the IMS catalog. It uses PSB DFS CPL00 for the initial load, and then it uses PSB DFS CP001 for inserting additional records after that. You should take an image copy of the catalog database after the initial populate. This will be required if you're using DBRC. Right? And on the next page here, we are simply showing you if the catalog is registered to DBRC, then the catalog database datasets are now marked as image copy needed in the recon. So that's protection with using DBRC and the recons. And then you restart IMS, and it'll it'll read the DFSDF, and it'll determine if the catalog is enabled, and it will read information in from the catalog. Right. Now, just a couple more things before I close. There's a new ACB Gen and catalog populate utility. This is called DFS 3U ACB. It replaces your existing ACB utility, which is DFS UACB 0, if the IMS catalog is enabled. And basically, what this utility does, this ACB Gen and catalog populate utility, what it does is within one step, within the same step, it'll update the ACB library, and that same information that it put in the ACB library, it'll also put in the catalog. So the phase one of this utility is the BBD Live and PSB Live members are used as input. It does the ACB Gen validation. Nothing is changed there. ACB member is then written to the ACB library with a new ACB Gen timestamp. And then phase two is where it's going to update the catalog. The generated ACB is then decoded, converted to the catalog format, and then it's loaded into the catalog. And then the DBD and PSB metadata is created and inserted. And this ensures validity and consistency between the ACB Live and the catalog. The new ACB Gen utility, DFSC, UACB, and the new catalog populate utilities are the only updaters of the IMS catalog today in IMS version 13. Right? IMS Online and IMS Batch regions will never update the IMS catalog data. IMS Online and IMS Batch regions will only retrieve data from the catalog. So that's why it's a trusted online source for metadata information. On to the next page, just a visual showing you or talking about that new ACB Gen and catalog populate utility called DFS3U ACB. The input is the recons, the DFSDF Worklight member, DBD lives, and PSB lives. It creates a sysprint output, updates the ACB Live, updates the catalog. You'll notice in the ACB Live there are two DD statements it requires. IMS ACB DD defines your IMS ACB Live dataset, and then there's the IMS ACB 01. This defines an ACB library dataset that contains the ACB members that are used to populate the IMS catalog. This DD statement is required. This DD statement must specify the same dataset defined in the IMS ACB DD statement. Right? So to ensure that the same dataset is referenced, a word of advice, just a suggestion here, code this DD statement with an asterisk as a high-level qualifier. Okay? The catalog database management, that's the next page. So the catalog is an IMS database, just like any other IMS database. So that means that the DBAs have to review and adjust database buffer pool definitions, make sure you've got enough buffer pools with the right sizes, and then, just like any other database, you've got to do routine management and maintenance, image copies, pointer checkers, reorg. The catalog database will need to be reorged at some point, right? If the catalog database is defined to if it's defined to recon, then HALDB online reorg can be used as a non-disruptive reorg way of doing that. If the catalog database is not defined to the recon, then HALDB online reorg can't be supported, and a reorg utility must be employed. Okay. Recovery procedures of the catalog, just like any other database, image copy, recovery, batch backup, all that stuff. That doesn't change. That's still the same. If the catalog database is not defined to the recon, of course, you don't have the same sort of recovery protection as you do if it's defined to the recon. And then there's the catalog purge utility, as I mentioned, that can go in and remove the catalog instances that are older than the retention period. The instances are not removed automatically. You have to periodically run this catalog purge utility, DFS3PU10, and here's the JCL for running this particular utility. So, in summary, the IMS catalog is a key element of the IMS strategy for integration, for simplification. More and more tools are taking advantage of this catalog. More and more features, IMS version 13 features, prereq the IMS catalog. At some point, if you haven't implemented the IMS catalog, I believe at some point you will be implementing the IMS catalog. It's simple to implement. It's basically an IMS database, and you basically have to, set up the parameters, load the data, and you're ready to go. Hopefully this presentation helped. If you have questions, my name is Deepak Kohli, and I should have put my email ID on here, but deepakk@us.ibm.com. Send me an email. Thank you very much.